In this video, we're going to discuss the chain rule. And that is, if you want to take the derivative of a composite function, where there's a smaller function inside of some larger function, then what you get is the derivative of that larger function, keeping the inside one inside of it, times the derivative of the inside function. So in words, the way I like to think of this is it's a product. It's multiplication. It's the derivative of the outside function times the derivative of the inside function. So if you look at our example here, and it says find the derivative of y equals 2x plus 9 to the 44th. This is a composite function, because inside these parentheses, it's not just like x to the power of 44. It's some function, 2x plus 9 to the power of 44. So the way that you want to do these is you want to first identify the inside function, which we've done here. So let's call that z. So 2x plus 9 we're going to call z. So the inside function is z, which equals 2x plus 9. And so therefore the outside function is now y equals z to the 44th. So the outside is z to the 44th. So now what we have is the derivative of the outside function times the derivative of the inside function. That's what we want to find. So we made an inside function and an outside function. We're going to find the derivative of each. The derivative of 2x plus 9 is just 2. The derivative of z to the 44th is 44z to the 43rd. So what we've done is we named the inside and the outside, and we took the derivative of each. The final answer, the derivative, is the product of the outside times the inside derivatives. So I would say y prime equals the derivative of the outside, 44z to the 43rd, times the derivative of the inside, which was 2. If you multiply these two things together, you'll get y prime equals 88z to the 43rd. So now that we've done that, the last thing to do is take whatever z was and plug it back in. So y prime equals 88 times 2x plus 9 to the 43rd. Alright, we're going to look at another example, and this one involving the natural log. So looking at this function, natural log of 2t squared plus 3, the reason I'm saying that you have an inside function is inside that natural log you have this 2t squared plus 3. So I'm going to say that the inside function, z, is the 2t squared plus 3. The outside then would become natural log of z. So to find the derivative of this thing, we need the derivative of the inside and the outside. The derivative of the inside would be 4t. The derivative of the outside, the derivative of a natural log, is 1 over whatever that thing is, so 1 over z. So now, f prime of t equals the derivative of the outside, 1 over z, times the derivative of the inside, 4t. If I multiplied those things together, I'd get f prime of t equals 4t over z. So the last thing to do, whatever z is, we want to plug that back in. F prime of t equals 4t over 2t squared plus 3. In this example, we're going to actually have to do this twice. And the reason is I actually have two parts. I have one function plus another function, with each one having parts that need to be done with chain rule. So let's start first with doing this 4e to the 2x. The reason that I'm saying that this is a chain rule is it's not just e to some power, it's e to the 2x, which is actually a function. So I'm going to say the inside z is the 2x, which would mean the outside would become 4e to the z. Taking the derivative of each one of those, the derivative of this would just be 2. The derivative of 4e to the z, we learned in the previous video, is actually just itself. So 4e to the z. So we multiply those two derivatives together. 4e to the z times 2. This is actually 8e to the z. And now plugging z back in, we have 8e to the 2x. So far, f prime of x equals 8e to the 2x plus. Now we need to figure out this right side, what its derivative would be. So we need to do e to the negative x to the 7th. So to me, I would say this negative x to the 7th, that is something more than just an x. So that's going to be our inside. The inside function here is negative x to the 7th. Or really, I should say z equals negative x to the 7th. So we'll say z equals negative x to the 7th. Its derivative would be negative 7x to the 6th. The outside function would be e to the z if I made negative x to the 7th z. Its derivative would be e to the z. So multiplying those two things together, e to the z times negative 7x to the 6th, I would probably rewrite that as negative 7x to the 6th e to the z. And if we plug our z back in, this is negative 7x to the 6th e to the negative x to the 7th. So the derivative of that right side thing is negative 7x to the 6th e to the negative x to the 7th. So rewriting out that whole derivative, f prime of x would equal 8e to the 2x minus 7x to the 6th e to the negative x to the 7th. So again, we know the derivative tells us a rate of change. So here we're going to look for a rate of change, and we're going to have to use the chain rule. This says a firm estimates that the total revenue R received from the sale of Q number of goods is given by the formula R equals the natural log of 1 plus 1,000 Q squared. Calculate the marginal revenue if the company sells 10 goods, or when the company sells 10 goods. So what are we really trying to find? Marginal revenue was the same thing as the derivative as we previously discussed. So we really want to find r prime of q. And in this case, we want q to be 10. So we're trying to find r prime of 10. So the first thing we need to do is figure out, okay, then what is the r prime of q? What is the derivative of this thing? So since we have something inside the natural log, I would say the inside function here, we're going to call z, would be the 1 plus 1,000 q squared. If you took the derivative of that thing, the derivative of the 1 would be 0, and the derivative of the 1,000 q squared would be 2,000 q. So the outside function, if I renamed the inside part of it z, would be the natural log of z. And its derivative is 1 over z. So r prime of q equals, we multiply those two things together, 1 over z times 2,000 q. R prime of q equals 2,000 q over z. Plugging z back in, 2,000 q over 1 plus 1,000 q squared. So we've got our r prime of q, but that's not what we really, that's what we need, but what we really want to find is this r prime of 10, the marginal revenue for 10 goods. So I would say r prime of 10 equals 2,000 times 10 over 1 plus 1,000 times 10 squared. And if you use your calculator to compute that, what you'll get is 0.199. I would say that's really about 0.20, because we want this to be in dollars, right? Revenue would be in dollars. So what this is telling me is that 0.20, the revenue is increasing about $0.20 per good. Or really, I could think of that instead of $0.2, maybe it would be better to think of that as 20 cents. 20 cents per good.